Dear learner, in our previous lecture, we have calculated load from our slab. Okay, here for floor finish, live load, partitional, slab, self weight, and how we have calculated that. If you new here, we are requesting you to visit our full playlist for previous lecture, that link given in description. Okay, so by using that load for our slab, we will design our slab using Excel sheet. So how we'll do that? First of all, we'll come here, and also I have added that floor plan so that you can practice in our website. So that link are also given in description. I'm requesting you to visit there now. Okay, let me, if I show you. Okay, no problem. Just find out the link given in description now. See, here we have a floor slab, and we have calculated load for that slab. You may remember from our previous lecture. So for the slab, we are getting that our long duration is 15 feet 10 inch and our short duration is 10 feet 2 inch. And always remember that our slab size will be from each of the beam to beam face to beam face. Okay, beam face to beam face. Always remember that. So it's done. And in a previous lecture, I have calculated area of slab, and I told you that I will when I will use AutoCAD file, then I'll show you how we can do it. So for that, if you take a rectangle here simply and click here on that rectangle over slab and go for properties, and see here 177 is our area, and as per 177 or other values, we have calculated it. Okay, now I will design that. So to design it, I will use Excel sheet. You will get this Excel sheet in our website, and if I go to our Excel sheet, here we have a huge Excel sheet to improve our working time. Now I'll go ahead, building design Excel sheet, and we have almost 12 Excel sheet for building design. And here I will use 2S slab design, as our slab is 2S slab. So a 2S slab design Excel sheet, and I will use that on USD method, and overall procedure of our Excel, of our design procedure will be in USD method. So I'll double click here. See, here our Excel sheet. Here our Excel sheet, and the video instruction for using Excel sheet are given here and here. You may go there for it, and also more resource given here. I'll go here, and only that value you need to change. So first of all, you have to change sorry value of f prime c. So what is the value? Let's say 3500. Value of fy. So in our country, or river grade are 500 megapascal. So if we convert it to in psi, then you will get it here. Then here the dead load. Okay, so we have to provide here the super dead load and floor finish load. Okay, so I have mentioned here for super dead load is our here partitional load. So our total load will be 35. And in previous lecture, I have told you that the self weight of our slab will not be considered in our this Excel, but if you create any Excel for your case, then you may use that, no problem. So as I have already pre-calculated or provide formula here to find out our dead load. Okay, self weight. Now I'll provide here a live load. So what was our live load? It was 30. Sorry, it was 30. Provide here 30, and our super dead load plus floor finish. What was that? That was 35. plus 18.75. So I'll submit. $7,550. Let's say 60. Our actual load is 50, but I'm for slab design, I'm considering it 60. Now width of beam. So as it is a two-story building only, so for it I'll consider our beam will be, width will be 10 and height of the beam will be 18 initially. Okay, so a dia of bar is here, the here provided bar in number of bar number bar 2, 3, 4, 5 like that, and here I have taken 3.15. So you may ask why I have taken 3.15. I have equivalent the bar size with bar diameter. We know now available bar size in our market is 8 mm, 10 mm, 20 mm, 30 mm, but in previously we have we used to use our bar size like number 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. So if I want to use 10 mm bar, then if I provide the bar size in 3.15, then it will be same. So if you only want to bar size like number 3 bar, then it's up to you. Okay, so here I'll provide 3.15 cos 3.15 bar size, dia of provided bar 3.15. okay, so I'm using that because I'm using finally I'll consider our bar size, our diameter of bar will be 10 mm, that's why. Okay, now let me clear you. So if we consider number of bar in number 3 bar, that means if we divided it with 8, so our total bar size will be 0.375, right? It's our bar size. Now if I take a new tab, and here if I go for that calculation, we know dia of a bar is pi by 4 into d square. So 3.1416 into 0.375 into 0.375 divided by 4. So now our area of bar size is here. Let's say here for number 3 bar, and now if we calculated that, let's say here, and if we use 10 mm bar, that means 10 divided by 25.4 into 10 divided by 25.4. Now see, its area is more than our number 3 bar, that was for bar 3, and that was for 10 mm. Clear? So see, they have a visual difference between our area. Clear? Now what? Now if I go for some change like this is 3 divided by 8, and here also 3 divided by 8. Now see, the value is same, and if I want to match with that both diameter, because in that present situation I will use diameter. I will provide in a drawing that use 10 mm bar, not number 3 bar. Okay, so for 10 mm bar, if I want to equivalent it, so if I consider 3.15 and 3.15, now see, this value is almost same, 0.1217, 0.1217. Clear? That's why I have considered 3.15. I hope it's now clear to you. Now I'll go here. That's why I have considered 3.15. To equivalent that size of bar with our 10 mm bar. Now half of continuous panel, I'll go to our floor plan, and here we have a continuous panel, and here we have also a continuous panel. We'll always consider the biggest one. It's 10 feet 7 inch. Then we can consider 5 feet 6 inch, almost 5 feet 6 inch. That means 5 feet 5.5 feet. Then shorter direction length and longer direction length. I'll go to AutoCAD file. That length was 10 feet 15 feet 10 inch. Longer direction length 15.833. And see, our shorter direction length are bigger here. That's why it's giving us a warning. Again, I'll go to our AutoCAD, and here 11.2. So 2 divided by 12 means, sorry, 2 divided by 12 means 0.16 something. So I'll go here, I'll provide here 11.1667, like that. So here now, this load from all, I'll not consider that all my, here, because already in our previous lecture I have calculated that value for partition all. Now if you do not want to calculate your value from here, and also if you want to provide your total all length, like what is the meaning of total all length? Here, total all length from that point to that point. What was our total value? Maybe 16, right? So from here 12, and also here 4. Total was 16. And for 16 feet wall, we have calculated that. As already we have calculated, no need to provide this value. Now we have to provide, most important, the case of our slab case. Now I'll go here. We're seeing that for our case, in that side we have a continuous portion, in that side we have a continuous portion, and also in that side we have a continuous portion, but in that side we have no continuous portion. So as per ACI code, here we have different cases, and we're seeing that our case is like 9. Why our case is like 9? Because in shorter side we have a free portion. If we go here, you see, in longer side continuous, in that side also continuous, in that side also continuous, and for that side we have no continuous portion. So what I'll do, I'll select case 9. Case 9. Clear? Everything is okay. Now here finally we have to change something. We're seeing that our thickness are 4.42 minimum thickness as per code. So if we go for 4.75, it's also okay, and I'll check here, depth check is okay. Okay, 4.75. So our final thickness is 4.75, and for 4.75, if we come here, our reinforcement here is, this is a reinforcement calculation. We know in our slab we have 2 continuous end and 1 discontinuous end, right? Here continuous and continuous, here continuous, and here we have a discontinuous end. Now if we see here, see our shorter direction spacing, that is this is for middle spacing, for mid span 14.2 14.24 and 14.24. Okay, but as per code, we know the maximum for 2A slab supported with beam, maximum slab shouldn't be exist 2T. That means 2T, 2 into thickness. That means 9.5. Here is our thickness 4.75. Now 9.5 and 9.5, and here we need discontinuous, and for continuous and discontinuous int, everywhere we are seeing that our minimum required extra top is 0.7, 0.7 nos, 0.7 nos, 0.7 nos. That means if we provide one extra top of 10 mm bar, our design will be okay. So what is the final output of our design? Our center to center distance of mid-span reinforcement or main reinforcement will be 9.5, and we'll crank on bar alternatively, and between two crank on support we'll provide 1 extra top. Okay, but we have another option to change. Must remember, before changing anything here, do not use or do not save a copy of it safely. Then I'll click here. Let's say I will provide 6 inch thickness and 6 inch thickness in both direction. Now we are seeing that our extra top requirement is in minus. That means no need of extra top, but obviously we'll provide a 80 mm extra top if required. That's it. So in this way we are able to design a slab very quickly. Now in our next lecture, sorry, I will not save it. Let's take it here, and if I come here, I'll see, okay, everything is okay. Now as per in this lecture we have completed perfectly. Now in our next lecture I'll show you how we'll use our cantilever slab. Okay, so for cantilever slab, actually this is also same. Let's cover in that lecture. No need to extend it for new lecture. Where is our cantilever? Yeah, cantilever slab. Okay, so for cantilever slab, similarly, or that f prime c will be 3500. It is also okay. Super. Our live load was, I have told you, I will consider 60 for balcony, and here our load for cantilever portion we have calculated in our previous lecture. What was that actually? Again, I'll go to our here, and for that cantilever portion, I will calculate the load. So from here to here, 3 feet 8 inch, and from here to here, that is 11 feet 10 inch. That means let's say 11.5, 18.5, or let's say 19 feet. All total all is 19 feet. Clear? Now I'll use our design parameter Excel, and here, okay, 19 feet, and we have considered that load will be 52 feet in previous lecture. I have forgotten it. So here 52 feet. Now I will go to our Excel, and our dead load will be 52 plus 18.5. Sorry, 70.5. Why 18.5? Because we have a floor finish of 18.75. Okay, 70.5 or 70.75. Let's say 75. And for grill, we may also consider 20 PSF. So let's say 90. Clear? So when everything is okay, see here we're what is our length of our slab. I'll go to our AutoCAD, and that is 3 feet from that portion. 3 feet 8 inch. That means 3.667. 3.667. Also bar, I will use 10 mm bar. For main bar and distribution bar also 3.15. So 3.15, that means 10 mm bar. Already have discussed. Everything is okay. And here we are getting our minimum slab thickness is 4.4 as per code. I will consider 4.5. Okay, 4.5. Now here depth check is okay, everything is okay, and here we are ready to ready for our slab. Here thickness 4.5 and total length 3.67 feet, and spacing of our slab for main reinforcement it is 3.15. that means 10 mm bar at the rate of 18 center to center, and for distribution reinforcement 10 mm bar at the rate of 13.5 inch center to center. That's it. So how easily we have designed our cantilever slab. So if you need those Excel, just visit our description of this video, you'll get it. Thank you very much. And in our next lecture we'll go for load calculation of our beam, then we'll go for beam design using Excel sheet. Thank you very much.